keep this this concept. Very hard to master. Let's look at this one again. This was the one we did last week. A bag contains numbered balls. Again, the way I think it made sense to some of you was when I did this. I drew a little pie chart and we said the probability of selecting a 2 was a half. So imagine half of it would be 2. A 3 was a third. So that means that would be a third, and that's selecting 3. So let me just write it in terms of fractions. That's a half, and that's a third. It says the remainder of the balls were numbered 1. So the remainder would be this guy here, which is also 1. The remainder. How would I work out the remainder? If that's a half and that's a third, how would I work out this remainder as a fraction? What would you guys do? Okay. Is it lagging for anyone else? Is it lagging for you guys as well?
Yeah, a little bit laggy for me.
All right. So, if I've got this whole pie chart or this whole pie graph right now, I said that's a half in black, that's a third. How would I work out what's remaining here as a fraction? Add them, add the half and a third, yes? So add the half plus a third, and that gets me 3 times 1, you do that whole hourglass, so that becomes 5 over 6, and then what? Subtract it from a whole. So 1 take away 5/6 is 1/6. So you know this is a sixth. What is the smallest possible number of balls in the bag? Well, if you know that 1 out of 6 balls was the number 1, again, 1/6 of all the balls in the bag was a 1, what's the smallest you can have? What's the smallest number of balls you can have? It can only be 6. Does that make sense? So if you said, oh, like there was 4 balls in the bag, then half of them can still be 2. But can you see you can't get a third of 4? And you can't get 1/6 of 4 as a whole number. That wouldn't work. So therefore the smallest number of possible balls in the bag would be 6. All right, let's try that again. Different context. Let's have a look at this one. These are really weird, which is why I want to do it. A colored ball is randomly chosen from a bag. The table shows the probabilities of the 4 colors. Again, the way we did this was we wrote these as fractions. That's it. So that's a quarter. That was 3/10. This is 1/10. And then to work out a red, we just added up all of these probabilities and then subtracted to find red. So 0.25 plus 0.3 plus 0.1. 465, 0.65. That means red must be 0.35. Again, 1 whole, take away 0.65. Which is 35 over 100, so 0.35 as a fraction should be 7 over 20. All right. Again, the question asks, what is the smallest possible number of balls in the bag? Anyone want to take a guess at what the answer should be for this one? Smallest number of possible balls in this bag. What would it be? If you haven't identified the trick, it's about looking at all your fractions and finding the largest denominator.
Sam, for
Yes.
the meme, your screen is black.
Screen is black. Let's start again. Stop sharing. And start sharing. Do you see it now?
Oh, it's still black, but it might load in.
Just wait, let me know if he comes up. Did it come up?
No.
You guys, it's on? It's working? Must be your internet, Matt.
I'll
Maybe-
leave and try
Maybe you want
rejoin.
to leave and come back on again. So yeah, what was it? Yeah, back to this one here. What's the smallest number of balls in the bag? What would you guys say now? What must be the smallest possible number of balls? Can you have 10 balls? Can you have 10? Can you get a quarter of 10? No, that's 2.5. So 10 won't work. Like I said, what's the largest denominator? 20. That's actually the smallest number of balls you can have. Because 20, all of these, look at these denominators, would 4 go into 20? Would 10 go into 20? So would all of these numbers go into 20? Yes. That's the smallest you must have. Your smallest common denominator. Yeah. That's the logic of it. So one more time, I'll write the answer. We'll do one last one. Okay, I saw another one here. Let's see. This one looks weird. Last one. A bag contains balls which are of 4 different colors. It is twice as likely to choose an orange ball than it is to choose a pink ball. So twice as likely to choose an orange compared to a pink. It is, what is it? Just trying to back in. It is 3 times as likely to choose a pink ball than a green ball. And twice as likely to choose a red ball than a green ball. All right, a lot of things happening. So I think what I'll do for this one, I'm just going to take a screenshot of that, or take a copy of that, and we'll start on the next page. So you can see your basic ones are fine, and those are the ones that you guys will get in your textbooks and whatever. These are more your exam style questions, the ones that really confuse you. And if you want to get to that 100% mark, you've got to really try to tackle these harder ones. 100%, not 90. 90 you can probably get away with. 100, you've got to know all of these as well. Let's try it again. A bag contains balls which are 4 different colors. All right, the colors are orange, pink, green, and red. It says that it is twice as likely to choose an orange ball than it is to choose a pink ball. So there are 2 pink equals orange. Does that make sense? Twice as likely, so 2 times the amount of pink is equal to orange. It is 3 times likely to choose a pink than a green ball. That means 3 times green is equal to pink. So pink is more likely. So 3 of greens is less likely, must equal to 1 pink. So pink is more. So 3 greens equals a pink. And twice as likely to choose a red than a green. All right, again, twice likely to choose a red than a green. That means red equals to 2 times green. All right, let me have a think now to make this easy for you guys. Find the probability of choosing each color. That's a hard one for you guys, I think. Because then you guys have in pink is 3 greens. Therefore, orange is 6 green. Yeah. I can do it. I just think it's a bit too hard for today, what I wanted to do. It's not exactly what I was hoping to do, but I'll finish it off. just to show you guys that if you don't understand it, it's actually okay. Well, here we go. I've got red as 2 greens. I've got pink as 3 greens. I've got orange as 2 pinks, but I know that 1 pink is 3 greens. So therefore orange equals 2 times pink, but then pink is 3 greens. 2 times 3 is 6 greens. So now we know that orange is 6 greens. Is anyone actually understanding this? You getting it? Cindy? No. No. Anyone at home getting this? What I just did there?
A little bit confusing.
A little bit confusing, but you actually understand the first lines, or no?
Yeah.
Okay.
I understand the line's just a bit confusing, how to work it out.
Yeah, I know. The working out bit is the algebra bit. Knowing that you're missing pink and you go sub in 3 green. I don't know, should I continue? I'll continue. Like I said, if you don't, it's okay. So what we've got orange, which you now know is 6 green. Plus, we've got pink. Pink we know is 3 green. Plus, green, which we know is just green. Plus, red. Red we know is 2 greens. And then 6, 7, 8, 9, 10, 11, 12. You're just doing simple algebra there. Altogether there are 12 greens. 12 greens means there are 12 balls, because orange plus pink plus green plus red, this was orange plus pink plus green plus red. So there are 12 balls altogether. What is the smallest number of balls in the bag? 12. Now I think this is going to get, I'm going to leave it, as long as that's all I wanted to do. The smallest number is 12. I'll leave it there. I'm not going to get you guys any more confused than you probably already are with that. Leave it. And then if it's just find the probability of choosing each color, I think you now know the answer to a lot of them. It's right here. There's 2 of them, 3 of them. But anyways, I'm not going to confuse you any more than I probably already have with that question. Leave it. Done.